All right. Well, today is a fun day. I've been looking forward to this whole week for a long time because my friend, the inspiring Sarah Puri, is joining us here. Here she is, and I'm going to start talking today and try to give you. So last time we left off with the shoulder joint, right? And I will eventually circle back to the shoulder joint a little bit and finish that up. Thank you for the two or three of you that actually responded to my email where I was asking for what you guys wanted me to talk about the rest of the semester. One person said fascia, so I will cover a little bit of fascia. And then there was a lot of feedback saying all three people that responded wanted to hear about the immune system. Two people wanted to hear about the endocrine system. One person wanted to hear about the nervous system or something like that. So I am definitely going to switch gears a little. All right. And because she's here, you can respond to the email if you want to voting. So the polls. Great. Well, we can talk about that. But I'm going to sort of jump ahead of where I would have normally been so that I can give you some background, some of the science context to do a lot of this meditation work that we're going to do this week with Sarah while Sarah's here. All right. So, meditation, right? Meditation has been around since the dawn, right? What is meditation? In some ways, it doesn't have to be this thing where I've got a timer and some contrived artifice to help you focus your mind, right? Meditation, humans have been meditating probably long before we were humans. Maybe not in the same intentional way, but prehistorically, humans and pre-humans lived in much less stimulating times. And so uh, they were probably often sitting, focusing their attention on something, meditating, letting themselves become one with their surroundings. With time, humans learned to organize that process of focusing attention. All right, and incorporated it into more formalistic structures. So we're going to talk about how those impact these meditative practices, formal meditative practices, influence the structure of. I like this picture because following my sand, but it's showing water near a beach coming up on sort of this sense of the self melting into blissful oblivion of union. All right. The roots of this formal meditation that I'm talking about are ancient. They're very ancient. A lot of people think about the East as being the source of meditative practice. Of course, the Buddha was but it's not limited to the West. We'll practice the East. Here in a picture of Persian. The Persian Empire was certainly a bridge. The the Eastern mysticism and the incorporation of to Western. I'm going to skip several millennia to right now. Meditation is at its probably highest point, highest recognition throughout the history of civilization now, currently, and it has been deeply popularized by like this wide panoply of technologies that are seeking to understand the mind, relationship. So, for example, Headspace. Does anybody use Headspace? You guys? There's this. So the Headspace app has been downloaded more than 30 million times. More than 30 million times. That's pretty incredible. I mean, that's 10% of the United States. I don't know if that's all in the U.S. That's a lot of people out there, presumably some of which are using the app on a regular basis. The website says it will teach you the life skill of meditation in just 10 minutes. Yeah. Yeah. 10 minutes is all it takes to be one with the universe. Insert some fun. So, they have these things now. There's all this accoutrement. You don't need just sand any longer. You can have this, but you can have this big, this big thing and get in it and be sort of isolated but connected with your environment. I like the picture because it was reminiscent of the sand I showed. The dawn. So, not necessary, right? You don't have to have one to meditate, right? But it helps keep them in the green. Really, what you need to meditate are these. Not quite these. These are 3D printed neurons. You don't need to be printed, but you do need actual. It's your mind is all that is really required to be able to meditate. So today, I'm going to start by talking about what a neuron is, just a little bit, and I'm not going to go deep into it. I could do a much deeper dive, obviously, but just a little bit of basics, just some basics, and then we're going to switch to the central nervous system, and I'm going to the nervous system in general. I'm going to talk a little bit about that, and then I'm going to just so this is the background, the anatomical and physiological background, and then we will move from that into an understanding of the effects of meditation on these structures. And then with about 15-20 minutes left in class, I will, with an eye on the clock, pass the torch and let her introduce her thoughts. Setting you up. So here is a very generalized structure of it. Okay? And when you look at a neuron, when you think about a neuron, you can I think of it in terms of a directionality of information. There's a flow of information, a flow of signal, a flow. If you want to call it information, that's fine. You can also just think of it as a flow of being. Something is happening, right? There's the manifestation of action, the directionality. That flow starts at the dendrites. These are sort of like the input terminals. And that information is going to come in the form of an electrical signal, which to explain would require a long lecture about charge dynamics across the membrane and transmembrane potential and channels, voltage gated, whatever. We're not going to talk. Maybe we will later. But anyways, there's going to be an electrical signal that comes in through here. It's going to pass through the body of the cell. That cell, yep, the soma, that's right. Soma, and there's two parts. There's the nucleus and the perikaryon. Perikaryon is the part that's near perikaryon. I used to tell a joke when I was teaching in Texas. Rick Perry. Yeah. There was like a famous story of this guy like shooting, carrying a rifle in a car. Maybe help you remember it. But perikaryon is the it's the cytoplasm next to it. And then so that flow is continuing through there, comes along the axon. And there's different parts of the axon. We're not going to worry about that now. But it comes to the axon. And when it gets to the axon, whatever processing, whatever information is getting processed in the cell, it's done. It's like done. So information comes in, gets processed, and then from the axon out, it's like, it's a done deal. It's just signal out down the axon to these little fingers, which are called telodendria, which are extensions of the axon, and they end in the synaptic knobs. And these synaptic knobs are going to synapse on dendrites of another axon, or maybe on a muscle cell. Right? We've seen that. That's the one thing we have seen. All right, you guys with me? Cool. All right, so here's a synapse, just so you can get a sense of it, a picture of it, to remind you of it. This is a colorized electron micrograph of it. So here in the abstract, we have one. This is like one little twig. It's one little twig of these. We're zooming in on just one of these little twigs, okay? And it is synapsing on some other neuron down here. So all this purple stuff down here, this is another neuron, a different. Yep. And synaptic knob comes down and has these little bubbles. We call them synaptic vesicles. They're full of a chemical of some sort. They can be different chemicals. It can be acetylcholine if it was going to be a muscle or some other cholinergic synapse. Or it could be serotonin, right? Or it could be gamma aminobutyric acid. Or it can be blah, 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 blah. There's a lot of different transmitters. But this chemical gets released and into this synaptic cleft, gap, and then that chemical is going to bind to receptors on the post-synaptic membrane, on the new neuron, the next neuron down the chain. It's going to cause some sort of event to happen in the next cell down the chain. That's the structure of a synapse. That's all I'm going to say about neurons, really. I'm going to have one other picture when I talk about white matter and gray matter. That's all I'm going to say about it. I don't. Was that? Most of the brain it's a mix. So a large portion of it is gray matter. I actually think most of it's white tracks. But all right. So is that like glaring? Should I bring this down? Yeah, down. All right, is that better? Okay, so this is a general schematic of how your nervous system works. You're going to have some kind of sensory nerve, whatever it is. It's out here in the periphery. It can be touch or sight, whatever. It's going to send a signal up to the central nervous system, which is the brain and spinal cord. It's going to like integrate all that and decide what to do with it, and then it's going to send a signal down to some effector, all right? And that can be a muscle or a gland or something like that, okay? So there's this information up, process, information, signal come down, all right? Basic schematic of how the nervous system functions. here's how we break it up. Here's how it gets organized into this sort of hierarchy. There's the central nervous system that's made of the brain and spinal cord, two separate parts of it that have different. Then there's the peripheral nervous system that has the somatic part, and that is basically things that control the skeleton. Then there's the autonomic nervous system. This is the part of the nervous system that controls everything else, your glands, organs. That autonomic nervous system has two parts, the parasympathetic and the sympathetic. We are definitely going to talk a lot about these two at some point. Not today, not this week, sometime. We're going to talk about sympathetic and parasympathetic. I'm unlikely to get to the slide that even references this, but I'll reference it a little bit, probably. And then just to not forget it, the enteric nerve. The part of your nervous system that's not really attached to anything else very well. It lives on the back wall of your abdominal cavity, and it is what controls your digestive. It has its own, you feel like your stomach has a mind of its own. In fact, it does. Yeah. You guys with me? I'm sorry I haven't put these slides up because I was finishing this. But yeah. Yeah, the peripheral nervous system is everything from, not the spinal cord, everything out from that. It's on the periphery. So it's all the spinal nerves, all the cranial nerves, all the ganglia in your body. It's all the nerves that are in your body that aren't the brain and spinal cord. Does that make sense? And it is distinct from the enteric nervous system, which is this thing that lives on the back wall. Let's not actually worry about it at the moment. I'm only mentioning it because in the off chance that I am able to talk about the digestive system sometime this semester, then we'll, and how yoga affects that, then maybe I'll talk about it. All right. Each of these slides, I'm telling you the same thing. All right. So this is the same thing, but sort of a different way, and I'm filling in some of the details as I go. So here is the central nervous system. All right. The central nervous system. And the central nervous system, I just showed you, is separated between the brain and the spinal cord. I showed you in that initial schematic how there's sensory information that comes up to the central nervous system, and then there's signals that come out, right? So the sensory information that's going up to the central nervous system, if it's going into the brain, we call them cranial nerves. If that sensory information is going directly into the brain, they're called cranial nerves. And the senses that get communicated via cranial nerves are the fun ones, the special ones. Nose, smell, sight, hearing, taste. And then there's the sensory receptors, touch, also fun. But they come in along the spinal nerve. They come in right here, and then they ascend through the spinal. Does that make sense? Pretty straightforward. And then there's going to be motor output, again, along either. And both of them are going to hit a range of effectors, cause some muscles, glands, or in fact, adipose tissue. Your fat is responsive to your nervous system. We can talk about it a little bit sometime. Spring. Everybody with that? So some of you said you like slides with text on them instead of pictures. You guys like to write. So one of those. Kind of the same thing again. So we have these sensory neurons. They're called afferent. Remember the word afferent, I am affected by something. Something came in and affected me. So sensory nerves are afferent nerves. or I caused an effect on something else, right? To cause an effect on something else, efferent neurons are the motor neurons. What's that? Yep, that's right. A before E. Is this all happy? And the interneurons are the ones in between. Actually, the vast majority of you is this. These interneurons. The vast majority of the nervous tissue in your body, like 98%, something like that. 98% of neurons. So they're associated with all the things that are great about being human, like memory, learning, whatever. Processing, imaging, consciousness, all that. The sensory neurons, there's going to be 3 different categories. There's ones that are going to monitor the inside of your body, right? So these are the interoceptors. And so, for example, when we did the pratyahara, oh no, was it pratyahara? Yeah, it was. Well, it was one of the meditations where I was getting you guys to like think about your internal organs. Remember that? Yeah, we started with the skin and then we went in and the bone. Those are interoceptors. They're real. You're not imagining that stuff. Those are real receptors that you can learn to connect with. Exteroceptors are the ones on the outside, your skin. So any of the outward-facing sensations, touch, temperature, pressure, sight, smell, heat. And then there are proprioceptors. Proprioceptors are important in yoga because they give you a sense of body position. They know with your eyes closed what position your body's in. They're in like joint capsules and stuff. Anything else do I want to say? Yeah, somatic versus visceral effector. Yeah, and that's simply just sympathetic and parasympathetic. Let's back burner that. We'll get to that. Okay, everybody comfortable with what I'm saying here? Yeah, so let's get on to the brain because this is bulk of what I'm going to talk about is just kind of related to a map. So I'm going to give you a very, very general, like, high school level, even less introduction to the regions of the brain so we can talk a little bit about it. The brain is about 750 to 2100 cc's. The size of your brain compared to her brain says nothing about your relative intelligence necessarily. That is a long since debunked myth. Although I will talk about in a bit, changes in an individual's brain volume happens with life and is correlated with cognitive function. And I'll give you the punchline: meditation affects that. Yep. Okay. So, 97% of the body's neural tissue is interneural in the central nerve, the brain. It weighs about 3 pounds. So here are the 6 regions of the brain. There's the cerebrum. That's the thing. When you say brain, that's what most people are thinking of, is the cerebrum. It's a big cauliflower. Yeah. I wouldn't want it. But, some zombies may. Vote the zombies out of office. Get the zombies out of office. Vote. Don't eat brain. I'm serious. Do not. You can get prion disease. It's real. People do. It's not called priya. It's called prion. Prion, it has nothing to do with you at all. Prion disease it's super fascinating, but I'm not going to talk about it now. So you can go look it up on the internet or ask me after. Yes, exactly. Or Jakob Creutzfeldt, or Kuru, or Scrapie. There's a bunch of prion disease. Bring it back. All right. There is the, let's go to the cerebellum. The cerebellum, this is everybody's favorite part of the brain to abuse. It's the part of the brain that gets saturated or drunk. Nobody gets drunk here, hopefully. But it helps coordinate complex motor functioning, that sort of thing. Yeah, did I say what the cerebrum does? Does all the higher orders, right? So conscious thought, memory storage, complex processing, decision making, and like analytics, etc. Parts of it are important in emotion, although not. It's not the center. So we hit the cerebrum or cerebellum. Cerebellum is important in yoga, but we're not going to talk about that. Then there's the diencephalon. Now, the diencephalon is actually, we talk about meditation. A lot of the effects of meditation are interactions between the diencephalon and the surrounding cerebral structure. See that. Diencephalon. What do we have? The thalamus and the hypothalamus. So anything that you perceive, if the thing that is calling you Jensen says, I feel this thing, I see this thing, I'm experiencing this thing, something was lighting up in the thalamus. All right? So for anything to get to the part of you that calls itself you, it's got to get through the thalamus. All right? The hypothalamus, you can't really see it here, but it is this little funnel-shaped thing that's connected to the pituitary gland down there. Is obviously hypo below the thalamus, and its job, it's got a complex job, but it is a sort of, it controls a lot of things. It's the control center for emotions, for various hormones. Like it's at the top of something called the HPA axis, which we will be talking about when we talk about the endocrine system. I'm going to reference it. Yeah, so hypothalamus is very important. Then there's the midbrain, also called mesencephalon. Encephalon is the sciencey word for brain. Mes, the middle. And the midbrain, the pons, medulla the medulla oblongata is fun to say at regatta. The medulla oblongata. These three parts are the base of the brain stem, the brain. All three of those parts handle a lot of the fundamental functions. Heart rate, breathing, etc. So last week when you guys were doing those cool pranayama things, you were targeting structures here in the medulla, and some in the, like heart rate, blood pressure, respiratory rate regulation. All those things are closely related. So, like for example, if you have a stroke that affects your medulla, you're gone. You're gone. Stroke up here, maybe like half your face starts sliding away, or you talk or whatever. But that is tragic. But this is really fundamental stuff, evolutionarily more ancient parts of the brain. So those are the 6 parts of the brain. Yeah, let me keep doing a little bit of neuroanatomy for another couple minutes, then I'll hand it over to Sar. So here's a picture of the brain, and this is going to be more important as we move forward because I'm going to talk a lot about how many of these relate to meditation. Am I expecting you to regurgitate the names of, like the cingulate gyrus, and here, like, not necessarily, no. The frontal lobe, occipital lobe, prefrontal, precentral, postcentral gyrus, all that stuff. No, but I do want you, when I make anatomical correlates to specific brain functions and meditation's impact on it. So that's the, but I'm going over this now. So there's these lobes to the brain. They're both geographically, or neuroanatomically, I should say, and functionally distinct parts of the cerebrum. Brain, we all know, is divided into two hemispheres, hopefully we all know. And this is divided down the middle. So here's one hemisphere, looks like the right hemisphere. It's the medial aspect of the right, also called mid-sagittal section. You guys know the sagittal. And then here's a lateral view of the left hemisphere. So we've got the frontal lobe, occipital lobe, parietal lobe, temporal lobe, the temples. So we learned did we learn the bones of the skull? Maybe I didn't. You guys learned? I did the temporal, yeah. Well, the lobes are named after, actually the bones are named after the lobes. Just a general term for you so you understand what sulcus is one of these valleys, and gyrus is one of the mountains, the peaks and the valleys. So a gyrus ridge along here, and a sulcus is these grooves. Those are general anatomical terms that are being applied to the brain, but here. So this, I like this one because it shows you this thing called the cingulate gyrus. We will talk about the cingulate gyrus. The cingulate is right above this thing called the corpus callosum, hard body. People think hard bodies are all like out here. The hard body's in the brain. Yeah. Right here, the corpus callosum is not labeled. But right above, we'll talk about that later. But for the meditation, we're going to talk a little bit about cingulate gyrus. Anything else on? Nope. So, yeah, cingulate gyrus. Getting close. Yeah, gray matter, white matter. Yeah. So this is my last slide, and then I'm going to. All right. So the brain has white matter and gray matter. You guys have heard that before, probably. Yep. And here's a cross section of the brain, a coronal section going through the crown of your head, right? Coronal section of the brain. And we look at it in cross section, and we see there's this rim of gray out here and all this white inside. What is that? What is that stuff? Well, turns out that the gray matter is actually colored gray because it is the cell bodies of the neuron, the soma. The dendrites and cell bodies all live up in the gray matter. And then they do all the processing out here on the surface, and they send their signals down through their axons. But their axons are covered in this stuff called myelin. I talked about it in lab a little bit, right? Yeah, the myelin sheath. Did I talk about the like fatty membrane wrappings? I believe I did. Yeah. And these myelin sheaths, it's just like insulation on a wire. You wouldn't want to wire up a house and put no insulation on the wire, would you? It'd be unwise. The same thing is happening here. And that white matter is, it's white because there are lipids in the membrane. Lipids being fat, right? So there's these like lipid membranes that form the myelin sheath. Yeah. Healthy fats are so important to eat for brain development. So I think that's all that I'm going to say. I have these other things here, astrocytes and cells. I don't think that stuff actually, they're probably just, but they were in the diagram. Okay. Are there any questions? No? Cool. So then I am going to skip. This is what we'll talk about on Thursday. We'll get through all that on Thursday, maybe. See? I'll bring it right here and pass the torch to Sar.
Hi, everybody.
I'll let Sarah introduce herself, but I've known her a very, very long time. She's an inspiring individual, a dear friend, an inspiring individual. She was, I think I told you. In fact, I'll let her tell.
Hi, everybody. It feels kind of, and I hope when we meet again, I can get everybody's name.
Oh, you can ask them now.
Okay, can we? Yeah, I would love to get everybody's name and maybe where you're from. And I'm Sarah. I live in Brooklyn. I used to be a lawyer. I'm retired. Been doing kind of facilitating meditation since about 2000, but have been a sort of dedicated practitioner. I recently was. It's not that much. Like some people, go on meditation retreats for like 3 years, but I think I added up my 280 meditations, so maybe that's like eight or nine. The longest retreat I've done is 3 months. I see you're making it. It's a lot, but so for me, it's great. Like if I didn't have I have a 5-year-old son. If I didn't have a son right now, I would be like, I love it. So for some people, it's hell, and I think, yeah, if it's hell, don't do it. But for me, it's like, it's kind of the best thing. And currently, my work in meditation is mostly teaching retreats for teenagers and doing an after-school program, some workshops with adults. So I'm going to talk about what is mindful. We're going to be paying attention to mindfulness meditation. And I was curious, do you guys know what that is already? Anyone have a definition that you want to it's that this isn't like a get it wrong or right. I'd just be curious, like, what are your thoughts? So, so some kind of relationship. Yeah. So present. Yeah. So presence and kind of your attitude, like how you're. Yeah. I know we don't have a lot of time, so I'm not gonna. I would love to actually. So here's my definition, which is
wherever you get, we'll
yeah.
just we can pick it up again.
Okay. Thanks, Tom. So this is my current definition, but as I was playing with this, we'll see that I actually am starting to have some questions. But paying attention to a present moment experience with an attitude of kindness, curiosity. And so I said it's not about making anything happen. Like when we're doing the formal practice, we're not trying. We're just trying. Whether it's disliking something, boredom, sleepiness, joy, it's all good. It's all the same. Uh, and we can be mindful doing anything, but again, the formal practice is a little bit different, and we'll talk about the postures related to that. But so then my question is, what's missing from seeing this? the relationship. And I did think about this definition because I think for some people it's only about one of the things. So here, so maybe as a in the training I was going to ask sniper beam, and so what to me this is missing. This is as and or you could even say like maybe some aspect of something I've been. So from my kind of training and background, I came through this as someone who had no, but I'd go on these retreats and eventually kind of a lot of that informed. It just resonated with me. But my training has been in secular mind. But one of the critiques of secular mindfulness is that there's this lack of, and for me, I think that kind of is true. It's like paying attention. You think about like what Google and the army and all these people are having learn mindfulness, but to what end? Like that really what we. And that's for y'all to figure out for yourselves where you stand on this. So the key elements: attention, present moment, experience, and this attitude of so. So I wanted to specify this. So like we have our field of awareness, right? Like is that hearing, smelling, but attention is the highlight, right? So probably you guys are aware of like the room. So we can direct our attention. And so in mindfulness meditation, we are directing our present moment because that's where we are. Uh, and again, the past and the future are usually just experienced thought in the present. We're here, but we forget that we're here. Like when you get lost in that thing. So we're building a different relationship with thought. Does that make sense? Okay. And so experience, again, this is what can we observe? Seeing, hearing, tasting, smelling, touching, and then we have. And one cool thing about this is it's really instead of having thoughts about your experience, which is a lot of times what like in your meditation, thoughts about it, it's like eventually what is, which is really to me, because I have been led around by my thoughts and gotten into situations and feelings that I didn't really want to get into, but I didn't how to let that. And then the last thing is attitude, which for me it was really funny. It took me a long time to actually like get this part of practice. Do all these things, but my like was like gonna crush this experience. And I would just get really tense, and I didn't understand, and that it's like that it's actually we can allow ourselves to and give this right, like a little bit of inviting, non-judging, curious, accepting, receptive, kind, loving, open. These are all just to get to the attitude. And part of the reason is it's really hard to be with what's happening there. And then from hating, so we can invite this both with like our breath. You guys, you start meditating some breaths to like whatever's happening. Also, just self-talk. Cool. Any questions about this? So in the I guess lab later, we're gonna mess around with different types of mindfulness meditation. One is one pointed where we're just being. It could be breath or body. And usually part of the reason why we do that is gather like when you guys were doing, did you all get to see totally lose track? right? Because the 1 point stability, and if you're gathered enough, you can be with whatever's seeing, hearing, thinking about what I'm. All of that flow you can be with, but you have. But so this is what I kind of know a lot about. But if you try this and if this sucks, but you still want to do some other kind of meditation, there's so many different. I've heard you've done, but there's like just relaxation, motivation, kindness, or other states you can activity, devotional, move, moving meditation, visualization. Some of these kind of relate, aside from maybe attitude. So it's like there's a lot out there. There's this just I encourage you to maybe check out something else, and maybe meditation ain't your thing, and that's fine. Maybe we'll save this for when we actually do it. Any questions?